lemma?
A proven statement used to prove another statement.
Yeah. A proven statement used to prove other statement. Okay. What is Euclid's division? We know that successive division in order to find out HCF. That is Euclid's division. Okay. Now, Euclid's division lemma. We know Euclid's division. Now, what is Euclid's division lemma now? What is Euclid's division lemma? It tells that for any two positive integers, the statement goes like this. Copy this statement. For any two integers, positive integer, or for any two whole numbers, A and B, there exists a whole number Q and R such that A is equal to BQ plus R, where R is okay. This is a statement, Euclid's division lemma. For any two positive integers or for any two whole numbers, A comma B, there are two numbers P and Q. For example, if I divide a whole number, if I divide 22 by 5, what is the quotient I get and what is the remainder I get? What is the quotient I get here when I divide 22 by 5?
4.
4, yes. And what is the remainder I get?
2.
2. So what is the division algorithm you have been writing from so many years? What is that? We know that dividend is equal to what is the division algorithm?
Divisor into quotient plus remainder.
Yeah. So for example, if you have, you know division algorithm, isn't it? You know division algorithm. Divisor into quotient plus remainder. I hope all of you are aware of this division algorithm.
Yes, ma'am.
When have you used this? Any idea? When have you used this division algorithm? To verify whether your division is correct. Have you used this?
Yes, ma'am.
In your lower
Yes,
classes, you have, after divisions, what you have done is you have taken this. You have taken this RHS and you have checked whether you will get the dividend. For verifying the division, you have already used this division algorithm. It's not new. It's the same thing what we have learned in earlier classes. The new form of this. It's been, the name is Euclid's division lemma now. Okay. So we use this algorithm to write the proven statements in order to find the HCF now. Is this clear? So what do we write here? What is this dividend here? In this case, dividend is 22. What is the divisor? 5. What is the quotient? Plus. Have you used this division algorithm, Shreya? Have you used this division algorithm? Pradyumna,
Yes, ma'am, we have used.
in which when I divide 128 by 13, what do I get? Thirteen what's that?
Ma'am, nines are
13 nines is 117.
117.
Okay. And then we get this remainder has 11. Okay. So we are dividing 128 by 13. We see that we are getting 9 has quotient and 11 has remainder. Now tell me the division algorithm for this. Pradyumna, tell me the division algorithm for this.
128 is equal to 13 into 9 plus 11.
So here it is dividend and this is divisor and this is quotient and this is remainder. This is of the form A is equal to B into Q plus R. Is this clear? Yeah.
Yes, ma'am, clear.
Now, what is algorithm? We learned Euclid's division lemma. Lemma is a statement. Instead of, it is a division statement. So this is a division statement. Right? So this is lemma. So what is algorithm now? What do you mean by algorithm? What is algorithm? It's a one by one step which is given for solving certain problem, right? Step by step instructions or method given to solve a problem. Do you agree to this?
Yes, ma'am.
This is just the step by step instructions given. Instructions. It's not only one instruction. To solve a problem, the step by step instructions is nothing but algorithm. Okay.
Okay, ma'am.
Note down till here. Now we learn about Euclid's division algorithm. So Euclid's division lemma was a statement. It was a statement there. And algorithm, it's a step-by-step instructions given to solve a problem. Euclid's division algorithm, to solve a particular problem, there is some steps given. So note down till here.
Dividing dividing A and B.
Very good. Dividing A and B. Dividing A by B because A was greater than B, right? Yeah. Then,
Yes.
so when we divide A by B, I get quotient and then I get remainder. So what is that I'll write here? So I'll write A is equal to BQ plus R.
BQ plus R.
Next to
Yes,
that,
ma'am.
this is the important thing what we have learned now. Any division algorithm should be written with this statement. Okay. Now what is step 2? Step 2, there is two conditions here. If R is equal to 0, you can directly find out HCF of A comma B. If R is equal, if you get remainder as 0 here, then HCF is the divisor itself,
B.
B. If R is else, if you've not used else, if R is not equal to 0, then what happens? Then
Divide B and R.
becomes the dividend. Then
B becomes a dividend and R becomes the.
yeah. So we do B becomes the dividend, or we can apply lemma to B and R. We can just write we apply lemma to division lemma to B and R. Then till when should we continue? Continue this till
R is 0.
continue
Till we get
this.
the remainder as 0.
Yeah, continue these steps till you get R equal to 0. What happens when R equal to 0?
We'll get our HCF. now.
Yeah, the last divisor is HCF. So this is actually the algorithm given by Euclid's division algorithm. So what I want you to do is, for a larger number, I want the division in the side and also these equations next to that, so that you don't go do with, no, you don't write only the lemma. I want the division also. Is that fine?
Yes.
Yes. So 420 is the divisor now. So what do we get here?
Ma'am, 424 is a 1680.
424 is 1680.
80, ma'am.
Okay.
And the remainder will be 102.
So this becomes the divisor, and now 420 becomes the dividend. One not two, what's that?
4 is ma'am.
Again Forza. Okay. So we get 408.
408, yes.
Yes. Then what do we get?
22.
22 or 11 or
12.
12.
yeah, 12. And then again
12 into 8.
how much is that? 90.
96.
And 6.
User.
So the last divisor which gives the remainder 0 is, just do this division for your support. Don't do it in working column. Deepta understood this division should be part of your answer. Okay, I don't want in some corner of your paper division and then statements. It should be part of your answer. Now for this part, write the Euclid's lemma. You can refer the division here itself.
Done, ma'am.
Yes. Now tell me, what will you write for the first one?
1782 equal to 420 into 4 plus 102
420 into 4 plus
plus
102.
10.
And I want one thing you people should notice. When you write plus here, please leave some gap here. It should look like different terms. So whenever you're writing plus, I don't want this plus attached to these numbers. I don't want it like a equation, a group of letters there. Is this clear what I'm trying to say?
Yes. Ma'am.
Yes.
Yeah, you should make a habit of that. Then the next one. Pradyumna, what about the next one?
420 is equal to 102 into 4 plus 12.
And try to see it should be aligned. Plus should be below this, equal. It should look aligned. Okay. And this one, Deepta, this part.
102 equal to 12 into 8 into 6.
Yes.
8 plus 6.
Shreya. She's not there. Adarsh. Yeah, Shreya, tell me. 12 is
12 equal to
6 into 2.
6 plus 6 into 2.
Just refer this division, this part of division. Okay. So you should have only this as your statement. Next to division, I want these statements. I don't want the division in your working column. And it should be properly aligned. Now, when you get the remainder has 0, that particular divisor, which is nothing but the last number here, will be the HCF. It should look like step-by-step instructions given to find the HCF. Got it? Is this clear?
Yes, ma'am.
So any question with Euclid's division algorithm should be supported with a division, and then to that particular part of the division, you have to write the lemma statements. And in order to find the HCF, we are doing the step-by-step lemma division, lemma statements in order to prove that 6 is the HCF of the given numbers. Each statement is a lemma, right? Isn't it? We are using it to prove the other statement. Do you agree to
Yes.
that?
Yes, ma'am.
Yes, ma'am.